Welcome back. This is the Tutor Wizard. I'm Adrian. This is Jasper. Oh, I know you're very nice. This is Jasper. She wanted to snuggle for a second. Please subscribe right here. Hit the notification bell. You'll get notifications for this series and a bunch of other ones. Okay, go do some math like everybody else. Today what we're doing is multivariable calculus. We're in chapter 2, which is double and triple integrals. Section 2.6 specifically is now doing triple integrals. Last time we did Fubini's theorem for triple integrals over rectangular boxes. This time what we're going to do is triple integrals over general regions E, and then we have 6 cases, just like the 6 kinds of dy, dx, dz, all the permutations of those. Now we're going to have to phrase what kinds of regions we have, front and back and left and right, bottom, top, just like these kinds of quarks, but different. Let's do it. Okay, now what we're going to do is we're going to have a solid region in 3 space. There's going to be 6 different ways of describing that. Plus then we're going to have, we can possibly, when we switch it to these cases, we can also use polar regions to phrase what the region is going to be like. And then what we're actually going to do later on, we're going to actually show you how to phrase this as what we're going to call cylindrical coordinates or spherical coordinates, and then have these change of variables in general. So this is going to get out of hand. But what we're first going to do is we're going to break our region into 3 kinds, our solid region E into 3 types. The first type is whether we phrase Z as a function of X and Y. The other 2 types we'll do in a second are going to be X as a function of Y and Z, or Y as a function of X and Z. Then in those cases, there can be, as we did with double integrals, 2 ways to phrase the type 1 or type 2 region D in the XY plane or XZ plane or YZ plane, respectively. Therefore, type 1 solid region says that we're going to take a domain D, which consists of points X and Y. Then Z we're going to view as Z equals U2 of XY, and this one is going to be Z equals U1 of XY. And what we're doing is we're viewing the solid as having a top surface and a bottom surface, so that we can view those surfaces as functions of X and Y. And then once we project that, once we fix that scenario and we know we have type 1, we're going to project that and get that we're going to integrate over a region D also, this double integral D, and then we'll have 2 different ways of phrasing this region D in the XY plane, whether it's a type 1 or type 2 region D in the XY plane. Let's do that next, and we'll get the first 2 forms of, and the first 2 ways of viewing a solid region in 3 space. All right, what we're going to do is type 1 solid region E. Now there's 2 subcases, whether we talk about type 1 region D or type 2 region D in the XY plane. So we have a solid region E. We're going to try and phrase it as a top and a bottom surface. Then that means we're going to phrase our function as Z as a function of X and Y. That gives us fixes our first bounds. So in either case it's going to be Z or DZ. And then what we're getting is we're interchanging these and swapping these the 2 cases we're going to get now, and that's from the type 1 and type 2. Therefore, this is the most familiar one that you're going to want us to try and stick to in all cases. What that does is it means it's keeping it in regular calculus, the way that you've always phrased that X is going to be the independent variable, and then Y will depend on X in the planar region, and then Z will depend on the 2 independent variables X and Y as our surface, and that's what we're used to, and that's how we've done calculus all the way up until now. If we have to do that, that's what we started doing in double integrals already, and you were like, I didn't really like that as much, but sometimes instead of doing that, if we have bounds, we can phrase X as a function of, oh, that says X is a function of X, that just says I could write that as, oh, there we go. There's X could be a function of Y in 2 cases, and then that means we could rephrase how we view this region E. And then we could set it up. Sometimes it'll be convenient to go from Y goes from C to D, X goes from G of Y1 to G of Y2, or G2 of Y, and then our Z is still going from the same functions, and we're going to get where we've interchanged the dx and dy. This is what they're talking about in problems when they say rephrase this, draw the region, and then retrace your bounds so you can compute this integral. Sometimes they set it up where this function is so non-elementary in the first variable Z possibly that I can't do it, and then they want you to interchange these further. For now, let's just do the other 2 cases. We're going to do this picture again twice essentially, but now what we're going to do is have a solid of type 2 and a solid of type 3. Type 2 solid E, now what we're going to do is we're going to say Y and Z. We're going to be in the YZ plane now. We're going to have to look at, and we're going to try and view the surface E as having a front cap and a back cap from this point of view. Everybody's looking at it from this point of view anyways, and or more analytically, we're going to say x is a function u1 of yz and x is a function u2 of y and z. What is that going to give us? It gives us this type 2 solid E, and then again we're going to have two cases in the yz plane. Now we're going to have two cases of whether we can have a type 1 or type 2 region D in the yz plane instead of the xy plane now. But this is how we define the triple integral over a general region E, phrased as type 2 solid E. We're going to phrase it as the double integral over the region D projected into the yz plane of this function from u1 of yz to u2 of yz of our function of xyz, which remember gives us a four-dimensional volume. What is happening? Multivariable calculus. Let's do the two cases in here. For a type 2 solid E, we're going to, again, what we're doing is we're viewing this as a front and a back face, or we have a function x, which is a function of y and z. Now in that projection into the plane, the yz plane this time, we can have a type 1 or type 2 region D. In the first type, we can have that y goes from c to d, and then z is two functions of y. It's going to go from h1 of y to h2 of y. In that scenario, our triple integral of a function of three variables over this solid E is going to be this iteration from c to d, then from h1 of y to h2 of y, and then x is going to go from u1 of yz to u2 of yz, and then so we're doing x first, which is a function of y and z. Then we're going to do z next, which was a function of y, and then we're going to do y, which will finally give us a number if we're computing this hypervolume. And this, similarly, if we have a type 2 region, now what we're going to do is we're viewing y as the dependent variable in the plane, in the yz plane. Y is the dependent variable, and then we have to flip that on its head. X is gone anyway, so it doesn't really matter. Now what we're trying to view is, instead of the top and the bottom in the yz plane, we have the sides we're going to focus on for a type 2 region. And then we have a leftmost and a rightmost. We're going to phrase that when we view that as, draw that as the yz plane. But really what we're saying is z goes from two numbers e and f, and then y is going from two functions of z, and we're going to get that we can phrase that triple integral over e of f of x, y, z as the integral from e to f, the integral from g1 to g2 of z, and then the integral of u1 and u2 of y and z. So x is now going from those two functions, but now we've rephrased it, and y goes from two functions of z, and our z is finally a constant. Luckily, there's only one more case, case 3, type 3 solids. Let's do those. Type 3 solid regions E. Now what I have, again, you see where we're going with this, hopefully. You're like, yeah, I saw where we're going with the last these scenes. Okay, there's 6 permutations. That means there's going to be 6 scenes. I got to do a scene for each type, and then I got to break it into the categories. So there you go. Now we're going to do 6 scenes. Scene 5 of 6, 7 of 9. She's cooler. This one is going to be what? We're now going to view the solid as having a left and a right. I like the Rubik's Cube analyzation. There's the front and the back and the top and the bottom and the left and right faces, and they have to move them to get them all jumbled back in. Now what we're going to do is focus on this side and viewing it as that. So we're going to have y is a u2 of xz and y is a u1 of xz. So we got those surfaces now. We're viewing them. And then we're going to project onto the xz plane this time. And then in the xz plane, we're going to have a type 1 and type 2 region D, which we're going to phrase in the next scene. Just hang on a second. What that tells us is our region, or our solid region E of type 3, is going to be viewing these guys as the independent variables and y as a function of x and z. And this will be our region E in set builder notation. Therefore, the triple integral of a function f of x, y, z over this solid region E of type 3 will be the double integral over the region D of the integral with the bounds u1 of xz to u2 of xz of f of x, y, z dy. Let's do the two cases of this one. Finally, for type 3 regions, we have two cases. Once we project that into the xz plane, we have a type 1 or type 2 regions. Type 1 I'm calling where x is going to go from a to b, and z we're bounding as two functions of x. And then the type 2 region D, we're going to reverse that. Z will be between two constants e and f, and x will be between two functions of z. Then we get the last of the two cases, and now this is all 6 versions of triple integrals over general regions. The triple integral over E viewed as type 3 with a type 1 region D is going to be from A to B, H1 of X, H2 of X to U1 of XZ, U2 of XZ, dy, dz, dx, and the other one is blah, blah, blah. This guy, this hot mess. The moral of the story is there's 6 different cases. This is not going to be easy at first. The first step is draw the 3-dimensional region, which is not fun or easy. Step 2, you have to phrase whether you're going to do type 1, type 2, type 3 solid region. And then you're going to project it once you pick that, whether you're going to phrase it this way or that way, you're going to project it onto that plane and get a region D in the XY plane or the XZ plane or the YZ plane. And then you have 2 choices of what your region is going to be once you view it in the planar region. So these are sort of lazy where I put both pictures in one, but when we actually go to do these in the next video, we are going to draw 2 pictures always, the region D, and then redraw the projection in the whichever plane you're in, so you can make sure that you can accurately sketch in the bounds of type 1, 2, or 3 solid E, and then type 1 or 2 region D in whichever plane we've projected into. Please subscribe right here, hit the notification bell. You'll get notifications for this series and a bunch of others. Next time we're going to actually compute some of these things. Better see you next time.